This lesson is on Electricity and Circuits, Part 2, Series Circuit Analysis. Make sure you have already viewed and understand Electricity and Circuits, Part 1. In this lesson, we're going to look at two different ways of connecting loads in a circuit. Either in series, as shown here on the left image, or in parallel, shown here on the right image. When we connect the battery, as shown in the left circuit, so that there's only one connection coming from the battery out to one lamp, and then that lamp is connected to another lamp. So then that lamp's connected to another lamp, and that lamp's connected back to the battery. There's only one path for the current to flow through these lamps. The current that goes through each lamp is going to be the same. It has to be because there's only one path. Now in the right circuit, you can see that the same three lamps are connected, but they're now, as the current comes out of the battery, it has three paths. It has the first path, it splits up and goes through the first lamp, so that would be I1, and then we'd have, it comes over to the next connection, and it splits up again and goes through the next lamp, I2, and then the remaining current will go through I3. So in a series circuit, there's only one path for the current through all of the different loads. In a parallel circuit, that means each load is connected separately to the battery, so that each load has a different current going through it. Now, remembering Ohm's law, voltage equals current times resistance. We see that the current, then, given the same amount of voltage, the current is going to depend on the resistance. So the flow of the electricity, the flow of the charge or the current, depends on the resistance in the circuit. So you can see in the series circuit, we have three lamps connected in series. So the resistance of each lamp is going to add to the next resistance, is going to add to the next resistance. So you're going to have these three resistance values are going to add together. So the three resistors are going to add together, meaning you have a bigger load in the series circuit, and the current will then be less, given the same voltage. In the parallel circuit, we have the same three lamps, but now each lamp has its own circuit, its own current flow. And you can see then, remembering that the circuit voltage equals current times resistance, the voltage across this resistor, then the current is going to be driven only by the resistance of that one lamp, which is going to be less than the series circuit. So in each case, in the parallel circuit, each one of these current paths is going to have more current than the total current in the series circuit. So the parallel circuit is going to have a lot more current flow out of the battery. Now, let's look at the schematics of each of these series and parallel circuits. So in the series circuit, as we were just talking, we have one path that the current can flow from the battery through the 3 loads, or the 3 resistors. So the 3 resistors, or loads, R1, R2, and R3, those 3 resistances then add together to make up the total resistance in the circuit. So R sub T here is then the sum of R1 plus R2 plus R3. And you can see then that the total resistance in the series circuit is going to be a lot greater than any one of the loads in the parallel circuit. So let's look at the parallel next. In the parallel circuit, we see that the battery voltage is connected directly across each load. So you have one circuit and the current going from the battery through the first resistor. Then you have another circuit, the battery is connected across the second resistor, so you have a second current going through the second resistor, and then you have the third resistor connected across the battery, the same voltage, and you have then a third current. So you have in essence I1, I2, and I3. Each one of those currents will be different based on the resistor in that circuit, because you have 3 different circuits. Each circuit only has one of the resistors that you had in the series circuit. So you can see the load, or the resistance in each circuit, will be less than in the series circuit. So that, remembering then, voltage equals, in Ohm's law, current times resistance. If the resistance is less, given the same voltage, if the resistance is less, then the current must be greater. So you have smaller resistances in each of the parallel circuits, but the current is going to be greater in each one. So when we look at the formula to calculate the total resistance in a parallel circuit, we can derive this formula that the total resistance is equal to 1 divided by the sum of the reciprocals of each resistor in the parallel circuit. So, in other words, 1 divided by the sum of 1 over R1 plus 1 over R2 plus 1 over R3. Okay, let's look at a series circuit and analyze then the current that's in this circuit that were shown here. We have a series circuit, and we have a voltage on our battery is given to us at 35 volts. We have R1 is 2 ohms, R2 is 7 ohms, and R3 is 5 ohms. So we want to know what is the voltage across each resistor, and we want to know what the current is through each resistor. Well, we know that the current through each resistor is going to be the same, because we only have one path for the current to go. So it has the same current, I, is going to go through each resistor. Now, remembering, of course, Ohm's law, voltage equals current times resistance. In order to calculate the current, we're going to need the total resistance in the circuit So we can divide that into the voltage to get then the current. So we're going to have to take the total voltage divided by the total resistance, R sub T. Well, R sub T, what's R sub T going to be? Well, R sub T is going to be then the sum of the three resistances. So R sub T will be the 2 ohms plus the 7 ohms plus the 5 ohms. So 2 plus 7 plus 5 is going to be 14 ohms. So now we can calculate the total current in the circuit. The total current is going to be the 35 volts divided by 14 ohms. And when if you figure that out, you'll see that that is 2.5 amps. So the total current through each resistor is going to be 2.5 amps. Only one current going through all three resistors. Now we want to know what is the voltage across each resistor. Well, the voltage is from Ohm's law is current times resistance. Well, now we have the current and we know the resistance, so let's calculate the voltage across each resistor. So voltage across the first resistor, V1, will be the 2 ohm resistor times the 2.5 amps, which gives us 5 volts. The voltage across the second resistor will be the 7 ohm resistor times the same current, 2.5, and so we'll have 17.5 volts. And then our third voltage across the third resistor will be the 5 ohms times 2.5, which will be then 12.5 volts. Now notice the voltage across R1 plus the voltage across R2 plus the voltage across R3, those voltages must add up to the total voltage. So the total voltage, V sub T, would equal then the 5 volts plus the 17.5 plus the 12.5. And lo and behold, that equals 35 volts. So everything checks out. As shown in this slide here. In summary then, a series circuit has one current path through all the resistors or loads connected in series across the battery. The sum of all the resistors, R1 plus R2 plus R3, equals the total resistance. In a parallel circuit, you have with three resistors, you have 3 complete circuits with 3 current paths. Each resistor has the entire battery voltage across it. The total resistance then is equal to 1 over the sum of the reciprocals of the resistances, as shown here. Now go to Blackboard and do the series circuit analysis problems.